Okay, so I'll try to make up some time, mainly because tomorrow we have a full session, right, where we can go all sort of over all the details about the Cosmos. But anyway, so Cosmos is really the testbed that's deployed in West Harlem in New York City. So the actual testbed is up in Manhattan. And when you, I don't have a picture here, you will see it tomorrow, but it's actually sort of upper left side of Manhattan. And the key technologies deployed in Cosmos are essentially the software-defined radios, millimeter wave stuff, and you can actually see the array here if you look at it. This, and I'm trying not to shine into Shankar's face with the laser. These two are millimeter wave arrays that are exposed, and you can see how they look like. A lot of optical networking. So the core of the Cosmos, and I actually think I have a slide, so I'll go there. And then, of course, a lot of networking and computing. And when I say computing, heterogeneous computing, we have all three types, as CPUs, GPUs, and FPGAs, right? So that's the basic idea. And it actually follows the orbit design, which is to sort of make it all remotely available. People can do experiments. Now, tricky part is, this is what we call the near portable node, this yellow box here. You have to be fairly strong to be able to walk around with this in one hand and the battery in the other hand. So, you know, near portable, right? Okay, the number of people using it, you can see it's a fairly large list. Testbed is officially available for research use for free, right? It's academic testbed. In theory, it should be for US focused research, but you know, who are we to judge, right? So it's actually open to everybody who wants to use the testbed. Now, in addition to being in New York City, and of course part of it is here, we actually have a fairly long reach to other places around the globe. In other words, we have optical connectivity to what's called the 32 Avenue of the Americas, which is one of the largest carrier hotels on the East Coast, where a lot of fiber from around the world comes in. And so there we have connectivity to, of course, the Ireland and to TCD, where we do a lot of collaboration under this program called COSMIC, Cosmos Interconnecting Continents, very sort of ambitious, as well as our friends in University of Wallace. And then, of course, Brazil and Japan, which are other two partners that we deal with. Given that this is giant connectivity, that means that we can connect to anybody in Europe, more or less, if it's a research, if they're attached to the research network, right? And this is fairly standard way of connecting, meaning we don't need too much effort to enable this, right? We just need somebody to talk to Jan, guys, give us a VLAN, we push it across, and then we can do experiments by directly connecting testbeds. And when I say directly, I literally mean machine in Ireland can actually talk to all our Cosmos services and devices without any interfacing, any firewall or anything else in between. Now, as I said, millimeter wave is the key technology that we are focusing on, especially, and you will hear a couple of presentations related to millimeter wave later in the afternoon and of course tomorrow, and you will see actually two demos related to millimeter wave. And I guess the main reason is whether that's perceived or true failure of millimeter wave in 5G, right? And most of it is due to the fact that people didn't really figure out this beam tracking issue and high mobility. So most, if you sort of look carefully, most of millimeter wave stuff is point-to-point these days, right? So given the spectrum scarcity and issues, right, we still try to figure out how to do that better. And you can actually see these XY tables. They're actually sitting in two corners. Millimeter wave array is mounted on top. You can move it around. And of course, the idea here is you first develop whatever you want to develop indoors with these highly scriptable, highly configurable constructs in the sandbox. And then when you're ready, you sort of walk outside and do stuff. And you will see, I'm not sure you will be driving around with the but you know, we do experiments where we put these in the car and sort of try to move it seriously beyond the XY stuff. Now, a couple of experiments. Tinjun is here, so you will have to talk to him in the interest of time. I will just breeze through the 3 slides, right? So virtualization of millimeter wave radio, interference-free analog stuff, and then, of course, efficient baseband processing, where we're trying to sort of push SDRs beyond typical limitation, right? The goal is, I believe, a gigahertz, right? Or 800 megahertz, let's say, of baseband processing, which is not trivial with the SDRs, right? It's more likely impossible than possible with today's technology, but we are trying. So some acceleration will need to happen, whether it's FPGA or something else. Optical technology, and this is, again, I think we'll hear a talk about it, so I'm not going to talk too much, other than to sort of say that there is this massive optical switch sitting in the core of Cosmos network. Everything is connected through it. There are these spools of fiber which allow us to sort of create long links. We do have dark fiber between the deployment area, which is, this is Manhattan, right? So deployment area is up here between 120th and 135th Street, Broadway and Amsterdam avenues, and 32 avenues of the Americas. So this is a fairly long length of dark fiber that we control, actually two pairs of dark fiber, which allows us to do, again, interesting experiments where we pipe things through either real or emulated, to call it that, long length of fiber. And again, you will hear more about this in the afternoon. Another thing that's happened in the meantime, on top of Cosmos, we have something that's called NSF Engineering Research Center. This is one of those large $25 million multi-year, actually 5+5 year projects that's sitting on top of Cosmos. It's called Smart Streetscapes, or CS3, right? And the idea there, and you will hear, I believe, at least 2 talks, maybe 3, about this in the afternoon, where the idea is to sort of look at these high precision, real-time street situational awareness that can help for livable, safe, and inclusive communities. And you will see actually one of the really nice experiments of how people with disabilities can actually benefit if we get our act together and put it all for good use. It's not clear how to make money on that, but societally it's good. So it's, hopefully community will do that rather than company, right? So anyway, you will see all that. And the one thing that Tracy didn't mention, I'm taking a liberty to mention, is that so since 2016, a lot of things were happening inside Orbit and Cosmos that are related to sort of ORAN or ORAN-related technologies. Most interesting one, of course, happening now for the last 3 years is what we call the TRACG Indigo project, where the idea is to look at the disaster management in the era of Open RAN. And the idea is if you have multiple operators, when disaster happens, and of course you can use this for DoD as well, when disaster happens, each of the operators loses some facilities. The idea is to sort of have a meta operator on top, or what we call the multi-operator, that will then collect resources from a number of operators and recover the network and support the mission. We are not going to talk more about this, but you will see one interesting component related. So there will be a talk about AI Planner later in the afternoon. Okay, and so last, and you heard it before, a lot of ORAN and OTIC testing happens every 6 months. So we do these fairly complex experiments that are part of the Plugfest, most likely related to evaluation of components. And so this is the last slide. All the stuff is available somewhere online. And of course, we'll hear more about it tomorrow.